Alright, now what we're going to do in this section, 6.1, is we're going to start talking about some angles and some trig on a circle. So the first thing we need to do is we need to go through some of these vocab words up at the top, and I'll draw it on 3 separate pictures so it doesn't get too messy. Alright, first thing, initial side. So when we're talking about angles, we have an initial side and a terminal side. The initial side kind of makes sense. It's the beginning side, and then the terminal side is the end side. So if I draw on this first diagram here, let's do the initial side in blue. So I'm going to draw a ray, and I'll call this one the initial side. So the starting side. All right, and then in red, let's just draw another ray over here in the second quadrant. We'll call this one the terminal side. Alright, so now I can kind of see the angle in there. So it starts with the blue initial ray, ends on the red terminal ray. Okay, and then the measure of the angle says the number that describes the amount of rotation from initial to terminal. So if I want the measure of the angle, I'd be talking about that opening right there. So I could take out my protractor and actually measure it. And we usually call it theta. So I'll go ahead and put a theta in there. Okay, now, this is going to get a little kooky in here, the clockwise, counterclockwise with positive and negative angles. So the first thing you need to know, positive angles go counterclockwise. So if I start over here on the positive x-axis, let's call that 0 degrees, and I go counterclockwise 90 degrees. So I'm going this way, opposite the way a clock would go. 90-degree mark would be straight up and down. All right, and if I kept going, the 180 mark, 270, and then if I go all the way around the circle, I'm back to 360 again. Okay, so that's positive angles. Now negative angles, if I just go over them in red, so again, let's start at the 0 degree mark here. Now if I go negative, I'm going to go clockwise. So let me grab a different angle besides 90. So if I grab something in here, I could call this negative 60 degrees. All right, or if I come over here, third quadrant, I could call that negative 150 or something like that. So again, starting from the 0 on this positive x-axis and then going clockwise for negative angles. Okay, now what we're going to do most of our angles in is this one here, standard position. Standard position says the vertex of the angle is at the origin. Okay, we know where the origin is. It's a 0, 0, so I put a big dot there. And its initial side is lying on the positive x-axis, so that's where we started the last ones. And then wherever I want to go, I can go positive, I can go negative. Let's do one here in the positive direction. Okay, so standard position is with the initial side on the positive x-axis over here, and then the terminal side ending up in whatever quadrant I give you. So if I gave you, for instance, 100 degrees, this could be 100 degrees opening. Okay, next word, coterminal angles. Two angles that have the same initial side and the same terminal side, yet different measures. Okay, so what this means is now, we might be going around our circle more than once. Okay, so let's look at our 100-degree angle we just did. If I want to name that again in a different way, look what I could do. I could go 360 all the way around, plus another 100. So I could say that 460 is a coterminal angle with 100 degrees. So again, same initial side, same terminal side, yet different measures. And then if I want to go in the negative direction, I could also name that 100 degrees. If I go this way around the circle, I could name that negative 260. Okay, so coterminal, same initials, same terminal, but different measures. All right, now the last word on this list is reference angle. A reference angle is the angle measured from the terminal side to the x-axis, always to the x-axis. That's really important. So let's look at our 100-degree example here. If I take the terminal side and connect it down to the x-axis, you can see I've created in here a little right triangle, and that's where all our trig is going to come from here in a little bit. So the reference angle is this little pocket in here. I'll try to shade it in kind of dark. And the goal of a lot of problems is what's the reference angle? So if it's 100 degrees, and then I say something like this is the 180 mark, then the reference angle should be 80 degrees. So it's a difference between the 180 and the 100. All right, so now I want you to try these two examples. So if you look at part A and B, I want you to find a positive angle and a negative angle that's coterminal with 30 degrees for part A and negative 140 for part B, and then also practice stating the reference angle. We'll go over these in class tomorrow, so make sure you fill those two things out. All right, now what we're going to talk about is we're going to talk about a different unit of measurement. It's called a radian. So if you look at the three circles down at the bottom of this page, we have a couple examples here. And what I want you to think about, instead of thinking about the angles now, I want you to start thinking about the arc on the outside of the circle. And as soon as you start hearing outside of the circle, you should be thinking circumference, which is 2 pi r. And we're always going to talk about what we call the unit circle, which is a circle of radius 1 unit, 1 whatever. So if I'm looking at this first example here, if I say the radius is 1 unit, and I ask for the distance around the circle, or the circumference, we would say the circumference is 2 pi r, but 2 pi times 1, so the circumference around the outside of the circle is 2 pi. Now, that measurement, 2 pi, is our starting spot for radians. So if you look at this little conversion here, here's what I have. I have 2 pi radians is the same as 360 degrees. So hopefully that makes sense. The distance around this whole circle in radians is the same as the distance around the circle in degrees. All right, now take a look at the second one. Hopefully this one also makes sense. So pi radians is 180 degrees. So if you think about 180 being halfway around the circle, well, then it should be pi radians. And then if pi radians is half the circle, hopefully it also makes sense that pi over 2 is a quarter way around the circle, or 90 degrees. So on the next page here, now we have the two conversions. So 1 radian is the same as 180 over pi degrees, and 1 degree is the same thing as pi over 180 radians. Same conversion, like 12 inches to a foot kind of thing. So if I look at number 1 and I want to do 60 degrees in radians, you take your degree measure, 60 degrees, and you're going to multiply it by 1, or for this one, you're going to multiply it by pi over 180 radians. And if you do a little cross-canceling here, you end up with pi over 3. Okay? All right, you guys try the second example, and just don't be scared by that negative. It just means your answer is going to be negative something radians. Okay, let's go the other way. So pi over 4 radians, if I want to turn it into degrees, now we're going to multiply by 180 over pi degrees. All right, here the pi's cancel out. 180 over 4 is 45 degrees. All right, so a lot of the first part of these lessons is going to be just converting from radians to degrees and degrees to radians. The last bit of this lesson is really from geometry. It's arc length and sector area. So arc length, first of all, if I talk about arc length on a circle, if I take arc length of a whole circle, well, then we're just talking about the whole circumference. But then if I start thinking about, okay, what if I don't want the whole circle? Maybe I only want a quarter of the circle, or 90 degrees. So if I want that arc length, then I just want this little piece here. Okay, so when I say arc length, I'm talking about some portion of the whole circumference. And if you look at the two formulas here that you have to memorize, the first one's straight from geometry. You take your angle over 360 times 2 pi r. In other words, some fraction of the whole circle in degrees times the circumference. So half the circumference, a quarter of the circumference, something like that. Now if you look at the next formula, this one's going to be a little bit new. So if 360 degrees is all the way around the circle, then 2 pi radians is also all the way around the circle. So if I'm talking radians, then it's the theta angle over 2 pi times the same circumference, 2 pi r. But in this case, the 2 pi's will cancel out, so the easier formula that you'll memorize is just theta r is arc length. And your book uses an S, so we'll use the same S. All right, let's try a couple. Let's try one in degrees and one in radians. So number 5 says, find the length of the arc intercepted by a central angle of 90 degrees in a circle with radius 16. Okay, so if I set up my arc length formula, it's going to be the angle over 360, so 90 over 360. That's supposed to be a degree mark. There you go. Times 2 pi r, 2 pi times 16. Ooh, there we go. All right, so 90 over 360 is just a quarter, reduces. And then if I do, the circumference would be 32 pi. Oops. Oh, it's stylus. And then the final answer, when I do a little reducing, would be 8 pi. Now remember, this is a distance, it's a length. So when I finally, 8 pi, there we go. Yeah, centimeters. All right, that's a little kooky. All right, let's do the same thing now with a radian measure. So if we look at number 6, my arc length is going to be the angle, so pi over 5, times the radius. And again, I'm using the shortcut formula, just the theta r. So it's theta times the radius. So if you do a little reducing here, I get 2 pi, and this is in feet. Okay. All right, you guys try number 7, same kind of idea, except this time I'm giving you an arc length and you're solving for theta. So you try 7. All right, the last formula, the ones you have to memorize here. Now we're talking about area of a sector. Now a sector is just a fancy word for a slice of the circle. So a slice of pizza. So if I want the area of this, it would be something like that. Okay, look at the formulas. They're very similar to what we just talked about with arc length, except instead this time we have a pi r squared because it's area. Okay, and we have our degree formula, and then we have our radian formula simplified a little bit. So let's do the same thing. Let's do 1 in degrees, 1 in radians. So find the area of the sector intercepted by a central angle of 60 with a radius of 9. So if I use the first formula, since it's in degrees, it's my angle over 360 times pi r squared. Okay, then if I simplify that up, I get 27 over 2 pi. Now again, this is an area, so I'm going to put centimeters squared on that answer. Okay, I'll let you guys try number 9, but let's go ahead, I'll do 10 with you. It's a little bit harder. All right, find the central angle. So we don't know the central angle, so we're trying to find theta of the circle that has sector area of 2 pi over 3 and a circle of radius 9. Okay, so we're talking about the second formula here because it's in radians. Let me write out the second formula. When it's all simplified up, it's just half theta r squared. Okay, so if I know the area is 2 pi over 3, I'll put that here. Half is a constant. Find the theta, don't know it, with radius 9 squared. Okay, now, hopefully you can crank out the algebra here, but if you just want to trust me a minute, do a little bit of algebra, I get theta is 4 pi over 243.